Okay, the next young man, Marty Sulloway, KC1CWF, is 13 years old. I met him at Boxborough in August, and after speaking with him for 4 minutes, I said, "You're hired. You're coming to the Youth Forum." And at least 8 different radio organizations have contacted me to say, "Did you get Marty as a speaker? Here's Marty. You'll love this." Marty Sulloway, KC1CWF.
Okay, very good. Hello, everybody. I'm Marty, KC1CWF. And today we'll be talking about some homebrewing fun and building equipment for contest stations. So who am I? Hi, as I say, I'm Marty, KC1CWF. I'm 14, live in Newton, Massachusetts, and I'm a very active radio operator, mainly involved with radio sport, contesting, and other activities like that, and homebrewing. So what is homebrewing? Obviously, we're here to talk about that today. Or why do we homebrew, more importantly? Well, we homebrew for another reasons, or the main reasons I homebrew are often for the cost. When I make something by myself, I can often do that for cheaper than it would cost if I were to buy a part or a piece of gear off the shelf. It can also be made to fit my needs. Sometimes what's available in the stores isn't actually what I need, and instead of piecing something together that would sort of do what I need, I can buy it myself. And it's fun. Working on something you're proud of, building it yourself is really exciting. And it's a learning moment, too. You don't know it all, so it's a great way to practice your skills, building something that you can use in your station every day. You can improve your soldering or experiment with new technology, so it's all really fun. So if you saw the beginning, that first slide, it mentioned contesting. So where does that fit into all of this? Every station for contesting is different and must fit the needs of the operator or operators in the station. Often, the exact piece of gear needed for a large, complex, or advanced contest station isn't on the market or doesn't even exist. An example would be that many contest stations are quite large and have many antennas and antenna systems, and they need to all be handled in a special way. And again, customization is needed to fit the needs of the operator. So my project and my example here for you today is antenna switching. An asset in contest station design and operation is automation, and removing as many of the unnecessary controls from the operator as possible. Automation of critical tasks is really helpful, especially after you've been in the chair for a long period, or maybe you haven't slept in 2 days. And I, at home personally, got very sick of manually switching my antennas every time I changed bands or needed to beam a different direction or something like that. And I was also afraid of selecting the wrong antennas then and again, maybe after 40, 45 hours in a chair, maybe sleeping for 2 hours, old, cranky, and it's easy to screw up critical things in a station that could really break something or have negative impact at that point. Many leading stations do have systems that will automate antenna switching and take those controls out of the operator's hands. As you can imagine, it's very critical that you don't select the wrong antenna, you don't break something, you don't blow up an amplifier or a radio in the middle of a contest. And there's many products on the market that do this and allow for automation of antenna switching antennas or maybe bandpass filters in a contest station. But there wasn't anything that really was on my price range or did what I wanted to do, so I figured I'd build a system that did what I wanted to do. So my project, as I say, is antenna switching. For my project, I had a few goals. I wanted the full automation of my station for switching of antennas and bandpass filters, the ability to take manual control after something breaks or a part blows in the middle of a contest and I don't want to end or stop. I wanted it to keep working, so I wanted to make my system, all the automation, invisible in case I needed to make it invisible. So if I could turn the power off to all the units I designed, that manual control could be used, and the station, the system wouldn't be there basically, and out of the way, and you could continue on in the operation. I wanted the system to be available to handle more gear in the future besides antennas, like bandpass filters, and I wanted to keep as much switching and coaxes and other distractions away from the operating position so I could have my area as clean and organized as possible to keep my hands on the keyboard and focus on being as efficient as possible. In the picture below, you see a board, a relay an off-the-shelf relay board that was used as part of my project to allow automation. And that actually is a built-in web server that can be controlled using some basic code to switch in and control antennas. So there's a little bit of hardware I used for this project. All of it was kind of cobbled off the shelf and wired together. Parts of it came from different places and kind of constructed to fit my needs. So I have a relay board, which is really a remote coax switch that can be in the yard, or I currently have it in my yard, that has all my HF antennas going into it. And that can be controlled using a normal control console, like is shown right. No, the slides didn't switch, did they? They switched back. I apologize, everybody. Sorry, there's a malfunction here. Like this box right here. And that can be used to switch antennas manually. That comes with the remote coax which I used, which is from a Maritron subsidiary of MFJ. And then there's also that other relay board that was in the previous slide, as I pointed out, and that's controlled over the network, and that's kind of the core of my system, which switches all my antennas. So it's not all magic. There's software behind that I designed that controls all of this, and the software for my whole project was written in a language called Python, and I have some basic programming skills, and I'm slowly learning. And once I feel that my code isn't working, is working well, I may release it to the public so people could do stuff with it. So just a quick workflow of how we get from a radio to an antenna and how everything is switched. Here's a quick example. The radio is connected to a computer, which is running a contest logging software in a contest. I think I have support designed to work with a number of contesting software packages, but in my case, I've been using N1MM+. And the software sends out a frequency broadcast over the wireless network, and that contains obviously some key information about the frequency and the mode that the radio is in. And that then goes to my software, which can decode that and figure out which radio it's coming from, and if what antenna should be there, and what's the best antenna on the band that I can use if I have multiple antennas, maybe for a second radio and I want the best antenna on one radio. And then that software can send commands to that control board with the network server that I showed in a few pictures back, which will then send 12-volt power out to the actual remote coax switch, which is stationed in the yard. So just a quick diagram that shows all this is right here. We have the radio again, which talks to the computer, which then can talk to the relay board that I bought off the shelf that has that controller in it. And that goes immediately to the coax switch, or that manual controller can go straight through and come around without going through the computer or the relay board. This all can be bypassed. And again, the switching scheme out of this box, there's a number of small, tiny relays mounted on a printed circuit board, which can switch 12-volt power over what's called binary coded decimal, with three different wires to choose 8 different antennas. The software that controls all this has a nice user interface, and compatible with Mac and PC and Linux as well. And it's not connected to that relay box I showed earlier, so that can be out of the way. And this is really powerful, and here's a few examples of this running fully automatically, and then a manual mode, and then just a testing screen all the way over on the end for use in a Mac operating system. So the results, this system has worked extremely well in some recent contests. I made close to 1,000 QSOs in a part-time effort during the CQWPX contest with just low wire antennas at home. I did not have a lot of time to operate, but it proved that the station works well. Haven't blown anything up yet. That's pretty good if you ask me. This whole thing is now being put to work in the use in a remote station, and there will be added support in the future for things like single operator 2 radio. We're developing some code and protocols to handle that, and stacking of arrays for receiving and transmitting, and electrically rotatable antennas. All projects that are being worked on here. This is all fun. I couldn't have done this without help from my amazing Elmers. So many people in this room, it's hard to thank everybody, but just to point out, Carol, thanks so much for having me here. Chip, W1YW, over there in the crowd. So many of you, it's hard to thank everybody, and I really appreciate it. And I got to learn a lot. I am still here. I can talk to you about it. I'm not in the fetal position under my desk crying in the corner. So I think this whole thing worked out well. Thank you so much. I appreciate it.